Guys and girls, it's Know It Time!
So guys, part 2 to this stuff. This is called geometric series. Again, is this a lot harder than? Not really. See, arithmetic, again, what I did with arithmetic is I did 3 plus 5 plus 7 plus dot dot dot. This was called an arithmetic series. The reason why? Look, there's these plus signs. It means sum. Arithmetic. Easy stuff. Series. Okay. And I give you a formula for this. This formula was not Tn, what about it? So that's supernova formula. Sn equals to n over 2 times 2a plus n minus 1d. That's supernova, that question. Yep. Good question. Haven't decided. If I'm nice, yes. If I'm mean, no. Depends. Depends. I forgot bracket. Next one. I'll show you the formula. So in the morning, we did 3, 6, 8. Whoa. My mind's not on it today. 12, dot, dot, dot. And this was called a geo sequence, or we talked about geoducks. So if you're ever in Chinatown one day, go to a seafood market, you guarantee to see a geoduck. And you can actually touch it and it tries to move away from you. Sorry? Keep them as pet? No. They eat them. Geosequence. The geosequence formula was Tn equals to AR to the power of n minus 1. There's a huge difference. The moment you deal with geometric, there's a formula. Now, I'm going to try what if I go 3 plus 6 plus 12 plus dot dot dot. I'm going to ask you to find sum of first 15 terms. Okay? First 15 terms. Oh, no. I'm going to give you an equation. Jason.
Is there going to be like 3 times 6 times 12 times
3, sorry?
Like, instead of addition, multiplication.
It's only addition and multiplication, that's it.
No. Will it ever be 3 times 6 times 12?
No. He will never ask for a product. Find some. Now, I can sit here for a few hours and try to figure this out, or I'll just give you this a unique formula. This is called supernova formula. Okay. Sn equals to A over R to the power of n minus 1 over R minus 1. See, A, a lot of you know what A is. A is what Canadians say. My cheesy joke for the day. First term. R to the power of n, yep.
And then
Take away 1.
that's not part of the exponent, is it?
No. A times R to the power of n minus 1. Guys, I want you to practice the formula. I'm looking for the first 15 terms. Have fun. So if I were to practice using formula, I'm going to just sub it in for you. So this is going to be 3 times 2 to the power of 15. Now, the minus 1 is on the bottom. It's not an exponent. So why don't we just work with this right now and just figure out what this is first before I do anything else. Okay. So 2 to the power of 15 minus 1 times 3. And your answer is 98,301. And this is called 98,301. This is called the geometric series. Whoa, divided by 1. Sure, we'll divide it by 1. Guys, if I divide by 1, you should get exactly the same thing. So this is the reason why I didn't divide by 1. Now, give you the next question. I'm going to give you a choice between two options. Option 1. Okay. I'm going to give you $80,000 flat out. $80,000 flat for your 16th birthday. Okay. Option 2. Here's option 2. I'm going to give you a penny. 1 penny on first birthday. Okay. I'm going to keep on doubling it every birthday. First B-day. Next thing is, so double it. Your second birthday, I'll give you 4 pennies. Second B-day.
Wait, should be 2.
What, 2?
You said 4.
No, I double it. I double it first. First you have 1 penny. Then you have 2 pennies.
You said
For what?
4. You said 4 pennies.
No, I should have 2 pennies.
Rewind it.
Okay, I'll rewind it. So guys, first, all the way up to 16th birthday. The question is, which one is a better option to take? Have fun. The whole concept of this is you got to figure out, is this a sum formula or just a regular TN formula? Loveline, is this a SN or TN formula? Woo, SN. Because I want to know how much money I have in total if I start collecting from day 1. Okay? So I'm going to use the SN formula. Plug it in right now. SN, or in this case, S of 16. Because I want to know my 16th birthday. A is 0.01 times 2 to the power of 16 minus 1 over 1. We're going to see if this is more than 80,000. If it's more than 80,000, I'm going to take this deal. If it's less, what is going on? Nope. Because it's on your 16th birthday. 2 to the power of 16 minus 1 times 0.01. So really, all you collected was $655. So the better choice would have been, I would take $80,000 and run. $655.35. So if someone gives you this option, take $80,000 and run. Okay. And just leave. Forget about option 2. Guys and gals, this is called geometric series. Now, what if I were to make it a bit more challenging? And I say this. 5 plus 20 plus ... 81920. Nope. 5, 20, and the pattern keeps on going all the way up to 81920. The question now is, what's my sum? I'm going to pause it. If I try to use the SN formula, what I taught you, SN equals to A times R to the power of n minus 1, R minus 1. The problem with this formula is I'm given everything except for n. I don't know what n is. N is missing. I can try to use the TN formula, but the problem is I didn't really teach you how to isolate for n besides guessing and testing. So I'm going to show you one last formula. If supernode 1 doesn't work, we're going to call supernode 2. SN version 2, 2.0. This formula is equal to A minus RL over 1 minus R. Guess what the L really stands for? Nope. A is the first term. Guess what L stands for? Last term. So if I look at this equation, I'm given the last term of my sequence right there. L is your last term. See, this formula is used when I'm giving you one of the terms somewhere in the middle, last term. And we just go ahead and use the formula. So I'm going to go A is 5 minus 4 times 81920 over R minus 1, which is 3. Let's write this 3 nicer. Sorry? Which is negative 3. And guys, let's just go ahead and solve it right now. See, this formula is used when you're given the last term. And this only works for geometric. So I'm going to work with you. I'm going to clear this calculator. I go 5 minus, I'm going to use brackets, times 81920. And again, I just work with the top part. Divided by negative 3. 109225. 109225. And that's the sum if I add everything together. Guys and gals, this is called geometric series. Is it that hard? No, not really. Your homework! Page! That's it. I can spend another day learning this. What, do you really want me to go another day doing this stuff? And do what with it? Page 5-3. Numero. I'm going to work with this some more word problems later, but for now on you get the basics first. We're going to start applications tomorrow. That's when the fun kicks in. 1 to 8. This is just to get your feet wet. I'm going to start applications, and that's where the true fun starts. And this ends my lesson for today.